what is it exactly that people should be working on if they want to actually solve the problem of aging? Perhaps the best way to repair something that doesn't work, whether it's from like a disease or an injury or even aging, right, is to just swap out that part.
Nathan, welcome to the show.
Hey, yeah, thanks for having me, Siim.
Yeah, you're one of those people I kind of knew I had to have on my podcast when I found your profile on Twitter or X, and it was kind of very interesting thing that you were involved with, which is, I guess, like whole body replacement and actual, how do we actually extend human lifespan beyond what is just achievable with regular diet, exercise, and supplements, etc. So I'm kind of very curious to delve into like, okay, how would it theoretically actually look like? Because, a lot of people throw around the idea of, we're in this age where humans are going to live hundreds of years with the advancements in AI and medicine, but no one actually is able to tell you, okay, how does it actually look like, or how will we actually achieve it? So I guess maybe we can discuss, bounce back some ideas of how to, what would a longevity look like in the next few decades. So yeah, I'm happy to have you on the show. Yeah, I guess we can start with your own backstory, because as I understand correctly from my research about your backstory, that you fell out of a PhD in physics to pursue longevity. So yeah, what made you decide that?
Yeah, I mean, it's a bit of a long story, but I guess it goes back to when I was doing my PhD. I was at University of Toronto doing a PhD in physics. It was in something not related to biology at all. It was like quantum optics, ultra cold atoms research. And I got 2 years into my PhD, and I had this just sudden realization that I was actually going to die, right? Like that this is no longer just like a theoretical concept that, is going to happen to other people. But no, it's actually going to happen to me and to everyone I love as well, right? So, and I thought that this was just horrible, right? Like that this is actually going to happen. Most people just put it out of their minds, right? They don't like to think about these things day to day, right? But for me, it just like it was just like a very, I guess, visceral realization. And the worst part about it was just like I didn't know anybody else who like thought about it this way either. It was just like, oh yeah, everything is fine. Like everybody's just pretending that it's fine. Whereas now that we're coming to this age where technology is advancing, science is advancing, maybe we can do something about it, right? But at the time, I didn't know anything about biology. I was just like in a physics program, and just really bummed out, I guess, depressed about have this idea that we all just have to die, right? And there's no choice. So I ended up dropping out of my PhD. I just couldn't understand like this working on physics in light of this like much bigger problem, right? So the order of operations in which you tackle like certain problems really matters. And for me, it made sense to try and do something about aging. So eventually, fast forward many years of just like stumbling around and finding stuff and just like going down many different rabbit holes. I discovered Aubrey de Grey on YouTube. He has like this famous TED talk where he, just lays out this idea that we can actually try to solve aging with science and so forth, and develop therapies against aging. So eventually, I ended up deciding that I wanted to get involved in some sort of way. Like I didn't have a background in biology, so I needed to take some online courses, and then in about when was this? And then in July 2020, so around the time of the pandemic, I decided that I would start a newsletter, which was just basically first and foremost, just a way for myself to learn about the space, right? So just force myself to learn, write about it every week. That's kind of like, so I always recommend to people to, if they want to get involved in the space, to learn and start like a newsletter or something or write about it. So yeah, I started a newsletter about longevity and investing, kind of like combining two things that I thought were interesting and like a unique angle. And I wrote about it on like the Substack for every week for several months, just to teach myself about the space. And eventually, it got kind of semi-popular. Some people started picking it up and retweeting it and promoting it, like Balaji Srinivasan, who eventually he introduced me to Eric Torenberg, who at the time was running the startup called On Deck, and they were building different communities in different verticals for founders. Basically, we're building stuff, and they wanted to expand into this longevity space. So yeah, I joined the team there at On Deck, building the first like longevity biotech fellowship program for them.
Gotcha.
And yeah, I was there for about a year and a half, and we did 2 cohorts of that program. And then eventually I spun it out as a nonprofit called Longevity Biotech Fellowship, LBF. So I teamed up with Mark Hamelainen, who was doing these kind of like more in-person intensive workshop retreats. We called them basically longevity camps, basically tried to get more people, like smart, talented, engineers, entrepreneurs, whatever, data scientists, AI researchers, to actually, make a career transition or whatever, get involved basically in this technical problem of trying to solve aging. So that was kind of my path. But, I also did a bunch of other things like in tandem with that, which, I started a fund with a couple other founders. So it's HealthSpan Capital. It's a VC firm. We've been operational for like 3 years, made like investments in 30 early stage longevity biotech companies, startups, and then also getting more involved in not just like the technical and like the VC side, but also the political side, which, just highlighting this idea that, this is an important problem. So we need to advocate for it politically. So also co-founded a nonprofit called Vitalism Foundation, which is basically trying to put forward this idea that we need to do something like drastic, right? We need to make this humanity's number one priority. What else could be more important than trying to save people from the thing that's basically killing like 80% of people today, which is, aging and age-related diseases. So yeah, so that's kind of my backstory. It's kind of long.
Yeah. I mean, it is in essence like the problem. If you solve that, then you have all the time in the world to solve other problems. Like if you'll have more years of productive years in your life, and we're not talking about immortality. Like let's say people have 20, 30, 50 extra years of productivity, then, they'll just advance in other fields as well, much faster in that sense. But you mentioned the Longevity Biotech Fellowship. So that's one of those like projects that kind of tries to outline, okay, what are the steps that we need to take to try to achieve some sort of longevity escape velocity or steps towards that. So there's also like a roadmap you had on your website. So maybe we can start with that roadmap so that people can get some actionable, not actionable, but some informative steps. Yeah,
absolutely. So when we were running this program, right, Longevity Biotech Fellowship, we were trying to find really bright, talented, ambitious people who wanted to work on solving this problem, and specifically solving this problem. Like one of the superpowers of our community and our program is that we screen and we filter and we interview very rigorously for people who share the same sort of like mission alignment. Because as you know, like this word longevity probably, it means so many different things to different people. And for us, we our goal is to try and solve aging. And but the problem is, once you find these people, right, and they come to your program, they don't want to die of aging. They want to solve this problem. The first question that they ask is always just like, okay, but what should I work on, right? And unfortunately, in our field, there hasn't been like a great, like, I guess, discussion or articulation of what is it exactly that people should be working on if they want to, actually solve the problem of aging. And if you go to any sort of like longevity conference, even if it's like a longevity biotech conference or aging conference, you'll find that most of the program is just like all these different research areas, right? Everybody's working on their own specific thing, but there's never like a big picture sort of discussion about like what is the plan, right? So you could imagine we're very much at the situation when we first started where it's kind of like, Elon Musk in 2001, right? It's just like he goes to the NASA website and he says, "Hey, where's the plan to go to Mars?" And he looks on the website and there's no plan, right? And we're basically at that situation, right? Like you go to the NIA, so National Institutes of Aging website. There's no, I don't even think they think of aging as a thing that needs to be solved. That there needs to be a plan, let alone like actually trying to
Right.
articulate a plan.
Yeah.
And most like biotech companies, let's say even longevity biotech companies, they won't explicitly say what they think is the plan. Usually these are like conversations that people have kind of like at the back of their mind, or like, maybe it's casually stated, but it's never being put at the forefront. So for us, the longevity biotech fellowship, we created this roadmap, this technical roadmap to solve aging, to be basically our way of saying, okay, given what we understand today, what are the plausible paths that one could potentially work on or develop that could get us to indefinite lifespan extension, essentially, is what we're trying to find. And the roadmap really has three features, which is one, that we wanted to focus exclusively on the technical paths to solve aging. So not things that are kind of like interim solutions where they're just like, oh yeah, well if I do this, like create a drug that extends lifespan, I don't know, like 5% in in humans or something like that, that would just wake up the entire world, and then they would put more resources into actually funding the thing that would extend lifespan indefinitely. We're not interested in that. We want to actually know what is the concrete technology that could get us there, given our current understanding. And then the other thing we wanted to do is try to make it more like actionable, right? So that we actually try to estimate like the amount of resources, both time and money that it would require to actually, put a decent effort into one of these like technology roadmaps. We're not saying that, if you put in X amount of money, you would, have success, but at least you could interrogate it enough to be able to say, okay, this is, we're reasonably sure like we gave it a decent try and we'll get a result one way or the other.
Gotcha.
Yeah, and the other thing is just trying to make it concrete for funders as well, and for people who want to get involved, so that they can see what projects are on like the roadmap, so that they could join. So
Yeah.
that's kind of the situation with the roadmap, and it has three sort of main technology paths, which we can get into, I guess.
Yeah. The first
further.
one is like replacement. So
Yeah.
that's like a replacement of organs and tissues, and also like brain replacement. So yeah, maybe we can start with the simpler ones, like replacement of we can already replace kidneys and those kind of things. So yeah, how would you like look like? How would you imagine this will look like over the next few decades of replacement of heart or lungs or liver, etc.?
Yeah. So the first branch on the roadmap, replacement. Actually, there's three. There's like replacement, there's biostasis, and bioengineering. So for replacement, the basic principle there is perhaps the best way to repair something that doesn't work because of whether it's from like a disease or an injury or even aging, right? Is to just swap out that part, right? So this is pretty commonplace if you're trying to like repair like an old car or something like that. Yeah, we don't get into like the minute details and try and repair everything at the molecular scale of a broken, I don't know, engine or like a carburetor or whatever. You just replace it, right?
Mm.
So that's the basic idea. And the question is like, how do you actually come up with the replacement parts, right? And there's many different ways that people are thinking about to do this. And so in the case of like kidneys, right? People mostly get kidneys from donors, so people who have died and they donate their organs.
Hmm.
But the issue there is there's just not enough organs to go around, right? Like there's a severe
Right.
shortage there. So um, to create more organs, right? Potentially, what you could do is uh, there's kind of like maybe three or four different major ways to do this, but one is to try to do like 3D bioprinting, right? So you're trying to like go from the bottom up. You're trying to do print like kind of like a scaffold, so like a sort of a structure that mimics like the extracellular matrix of this, of this organ and of the tissues in the organ, and then you try to populate it with like stem cells or cells derived from stem cells, right, to get all the right all the right cell types and so forth. And this is extremely difficult. Like I don't think we're even close to getting this done. Like people have printed like 3D bioprinted very very simple organs like a bladder or something, which is basically just like a bag, right? And that's fine. But it's just like a very difficult technical problem. And maybe in the future it would be possible. But from my vantage point, and this is just my opinion, it doesn't seem likely that we'll be able to 3D print like a whole kidney or like and also the rest of the other organs. Like you would also need,
Right.
if you were thinking about aging, like all your organs are aging, so you'd have to do like kidneys, heart, lungs, everything. It just seems very difficult, like unimaginably difficult to me. So that's okay. So that's interesting. People are working on that. There's other stuff that's really interesting, which is basically instead of going from like the bottom up, maybe what you can do is leverage biology itself. So like, through billions of years of development and, evolution, biology is very good at self-assembling stuff, right? Like just creating organs by themselves. So there's been a lot of interest in xenotransplantation. Do you know what this is?
Yeah, like foreign transplantation, then like foreign body.
Yeah. So you can do something like cross species. So there's a couple of companies, eGenesis and United Therapeutics with their, I think, Revivicor and so forth, where I think just recently in the news there was a story that became popular where they basically did this transplant of a pig kidney that had been genetically modified to remove certain like endoviruses and stuff like that wouldn't be compatible with the human immune system, and did like 10 gene edits in this pig and took its kidney and transplanted it into a human. So this is one way to try and tackle the problem and develop more sources of organs and tissues and so forth, which is great. And it's really cool that people are working on that. But then the last thing is, okay, what if we could go further than that? Like what could we do that's kind of like that, but better, like extend it? And the better would be to do human, right? To get human organs and grow them. But the issue there is, unlike a pig where, it might be ethical to, to grow a pig and so forth, you can't grow like an entire human with like a
Right.
brain and so forth. That's a whole person.
Like the Matrix.
Yeah, exactly. You couldn't do that, right? Like that's totally unethical. So what you actually want to do is just grow like the organs, like
Just
like
organs.
most of the critical organs, or maybe just like the body, whatever you want to call it, without consciousness, without a brain, and it may be possible to do this. So where should we begin? Okay, so let me walk you through this.
From what
Okay.
material? Or
Yeah. So in 2018, something happened. Something really important happened. Like one of the biggest breakthroughs in science that basically nobody talks about. Do you know what it is?
no.
Okay, so in 2018, I think this made cover of Science, but basically, primates were cloned for the first time in 2018, right? And it was like a pair of monkeys. I think it was a collaboration between a group in China and in the US. And basically, even though sheep had been cloned for a really long time, right? Like that was back in like I think the 90s even, or early 2000s. I can't remember. Primates had not been able to. We hadn't been able to develop the technology to clone primates. And so in 2018, you were able to clone primates. So then this basically opens up this idea that, it seems plausible that you could also clone humans, right? And of course, this is a huge, ethical debate and so forth. But it may be possible, right? So then the question is, okay, you could clone like a copy of yourself in principle, right? And it would have all the say all like the compatible organs. It's immunologically basically identical, right? So that would be useful, right, if you wanted to swap out your parts. But the problem is you don't want to create like an actual whole human with consciousness and so forth. So if you wanted to do something like this, you'd have to create a clone that never has the capacity to develop consciousness or have like the conscious forming parts of the brain. Right. Yeah, exactly. You just want the body, right? Now, is this possible? Well, actually, nature gives us a clue, like a proof of concept that this might be possible. So there's there's a congenital birth defect called hydranencephaly, where basically most of the forebrain and cerebral hemispheres and so forth, they don't develop, but most of the lower functions are still preserved, so that this fetus that has this birth defect, if they're allowed to develop to like birth and also like actually given life support, etc., like feeding and so forth. There are cases where these patients are able to develop to adulthood, right? Like actually full maturation of their body and so forth. Although for the most part, I think for legal purposes, they're not considered like conscious. Like they're usually taken off life support shortly after birth or whatever, and they die. But this gives you an idea that it might be possible to create a body without any of the conscious forming parts of the brain. None of the neocortex and so forth. So yeah, I mean the inside their cranium, it's mostly just cerebrospinal fluid. So it's possible, right? So then basically what you want to do is combine these two things. What you would want to do is you want to clone, so do some sort of somatic nuclear cell transfer, somatic cell nuclear transfer, cloning, and then you'd have to do some sort of genetic construct, right? So do a genetic modification that would essentially knock out the conscious forming parts of the brain, and then you would be able to allow this to develop to maturity, and then this is the tricky part. So the tricky part is, what do you do with the organs? You could do just like one organ at a time, kind of, or kind of transplant if you're to swap an old kidney with a young kidney, or you could do a multivisceral organ, so like the whole organ system. So as a matter of fact, I believe when people are doing like heart transplants or lung transplants, they usually do both at the same time because they're interconnected. It's actually just easier. But you could actually take that one step further and like basically do all of the kind of like thoracic, visceral organs all interconnected all at once, because then there's really only like 4 kind of like arterial or venous connections that you would have to reconnect and so forth. So that way you could potentially replace all of your old aged critical organs with younger ones. So there's that potential. And then the other thing, I guess the third potential path is to do a head transplant or something like that, like or body transplant, depending on your perspective. Which people have done on model organisms. So successful head transplants, or well, semi-successful head transplant, have been done on mice, dogs, even monkeys. So back in like the 70s, there was a pioneering transplant surgeon, Robert White, who had done head transplants on monkeys, and the monkeys were able to survive for like I think like maybe a couple days after this transplant. But of course, those monkeys were not clones, right? So there's going to be issues with immune response and so forth. So that's kind of like what you could potentially do to try and solve aging in the body, but we haven't even talked about the brain yet, which is a bigger problem.
To kind of I guess if I understand correctly, then the most likely scenario would be that you grow this genetically clone of yourself from the fetus. You would grow it, but it doesn't develop the consciousness through genetic editing, and you have the same organs and everything else like that. It grows into the body, full mature body, adult body, and then you take the organs from that husk and you put it into your body. I guess the other way could also be that you take your trying to put your consciousness into that new adult body, like a younger version of yourself, which I don't know. Like personally, I don't think that's very possible because it's very dependent of what constitutes your consciousness and how do you like define it, because we don't understand what makes you you, like where does your consciousness emerge from. We have like not a clear idea of where is it like located. Is it in the brain? Is it in the nervous system? Is it the entire body? But let's say if you like replace a kidney, you're still you. So but at some point, where do you lose yourself? Like, is it only at the edge of the brain? Is it at the edge of the heart? Or so that's I guess like something very perplexing at the moment.
Yeah, it's funny if you do this exercise of like, okay, I want to um, solve aging, or you want to live indefinitely or have the choice to live for as long as possible. I think all roads eventually lead to this question of like the hard problem of consciousness.
Yeah.
You can't get around it, unfortunately, especially when you're talking about the brain. Yeah.
Yeah. But that's one way to like one by one trying to replace the organs. So yeah, I guess that is the hard problem of consciousness that we would face, like with the brain. Like, I guess brain replacement, how would that look like? Or yeah.
So this is where things get a lot harder. So in some sense, like replacing the body, or maybe just the organs, just like developing the replacement parts, doesn't seem too infeasible to me. And actually, there are people working on this in different in different forms. So actually, that doesn't bother me too much. I think that could be a solved problem. The bigger problem actually is definitely in the brain, right? Because even if you could replace all the organs and so forth, or even your body with a younger version or whatever, your brain is still probably going to age. Now, that being said, like a younger body, probably like there might be a parabiosis effect where, the younger body rejuvenates the brain, or, a younger body is better at supporting or slowing down the aging of an older brain. So there's that part to it as well. But, given a long enough time scale, there's probably going to be replacement necessary, or trying to address at least the aging brain, right? So what do you do there? You can't, just grow a new brain and replace it, right? Like that doesn't make any sense. Your consciousness would be destroyed, right? So what you can do is you can do progressive replacement. So what you can do is basically replace parts of the brain, like small parts at a time, with engineered like neural tissue grafts, right? That are, arrange the cell types in the right sort of layers and so forth. And because the brain has like a plasticity, right, it can accept, in theory, these kinds of like modifications over time and kind of like incorporate them. So we know, like, so I recommend everybody go out and read a book by Jean Hebert. He, at the time, was a researcher, professor at Albert Einstein College of Medicine in New York. He's now since actually being recruited at ARPA-H, which is a government program at the U.S., kind of like a DARPA style, biomedical sort of moonshots program, and where he's heading out research there, basically on how do you repair like the brain with replacement grafts and so forth. Anyways, you should check out his book, Replacing Aging, and it basically lays out like this potential strategy. And in his book, one of the proof of concepts that he uses to make this argument that it's possible is these cases where people get brain cancer, a certain type of slow growing brain tumor. I think it's some sort of glioblastomas, and basically, or glioma rather. And basically, when these tumors develop in, let's say, the language center of your brain, if the tumor grows slowly enough, actually these patients never lose the ability to speak or lose their ability for language, because the brain is actually able to compensate and migrate those language functions to other parts of the brain if you do it slowly enough. So in that same vein, like you could potentially replace parts of the brain by doing it slowly, and those functions could migrate in that situation. Yeah. But it's tough. I'm not trying to sugarcoat it and say like this is like very easy, or that we'll be very successful in doing this within the next 10 years or whatever. People are trying, and we should definitely try. But
Right.
yeah, at least there's a path forward where you could plausibly see how this works.
Mm. And what would be like the biggest, like, is there any like breakthroughs that would need to happen, like in AI or some other biotech field, or?
Ooh, yeah, I mean, AI would be generally useful if you're thinking about just like, could you just create more even human level researchers to work on the problem, right? Like that's just like a lever that you could apply. And then I don't know, I can't speculate on like super intelligence and like creating, super genius AI agents that would solve it for you. At that point, you're just, I don't know, you're kind of hoping that, God comes out like Deus
Right.
Ex Machina, literally just God comes down from the stage or whatever and solves the problem. But if you're talking about just like, yeah, what breakthroughs, I think, first of all, I need to say that it's just like, it's a very niche field. There's not that many people working on brain replacement and in this particular field. So just getting more people involved, there's a lot of like low hanging fruit just there, right? Just, leveraging what we know, or just like researching more in that direction, right? But then, yeah, the thing that I'm really, really like excited about is, the fact that Jean Hebert is, at ARPA-H heading this program where, they're going to put, potentially hundreds of millions of dollars into research in how to, develop these neural tissue grafts and then actually get to a clinical proof of concept. So I think the first thing that they probably would be interested in is like stroke or maybe traumatic brain injury. Maybe this might be useful even for the military, right? Like when people have like a brain injury, how might you like repair that first, right? So like an acute injury, try and develop these grafts, see if you can restore function. And I think that could be done actually, or at least test it, do a thorough kind of like reasonable attempt within the next 5 to 10 years. So, but I think the main thing is like, even though people have done sort of like, brain cell transplants, like there's several companies working on this for like Parkinson's, right? Like transplanting dopaminergic neurons into the brain and see if that like can restore function. So like that might be an early proof of concept of just like, yeah, you can at least put in new, brain cells into the brain and they can integrate. But then, yeah, moving forward, you'd have to show like, if you're doing like larger grafts, that this would work in a primate model first, and then into humans. But like, I think a lot of the challenge is, yeah, how to actually do that. What are the right cell types? How to actually configure and engineer these grafts in the right way? Because like, yeah, it's a complicated
Yeah, I guess
engineering problem.
they just need to try it and do a lot of experiments. That's how you kind of make the most progress. And I guess another thing that you could think about is just becoming like a cyborg. So like instead of having biological organs replaced and the tissue replaced, you could just why not just have mechanical tissue and become like a cyborg, and then just try to figure out how do you maintain the consciousness or the brain. Like maybe you just have the brain and the nervous system, and everything else is like a cyborg version.
Yeah. So there are people kind of working on pieces of this and parts of this kind of like idea of like, yeah, synthetic replacements. So, people already there are people today who have like artificial hearts, right? They're not very good. They don't last very long. But it might be possible. And then if you're thinking even like one step above that, just like, okay, what if we replace the entire body with like a synthetic body? Like literally the only thing that the body does is it's a life support system for the brain, essentially, right? So how could you replicate that, artificially? So there is a group at Yale that I think it was last year they published some interesting stuff in brain perfusions. So basically, they took out the brain of a recently deceased pig and they put it in this kind of like bath, I would say, some sort of like perfusion of like I guess it's blood, but other like metabolites and other like compounds. And they were able to measure like brain activity for like I think it was months. It was at least weeks,
Wow.
right? Afterwards. So yeah, and there's a company forming around this, mostly for I think they're using it as a platform for brain research. It's called Bexorg. Anyways, the platform at the in the paper, I think it was called Brain X. And anyways, point being is, it might be possible to, create just like an artificial life support system for the brain. So that
Mm.
might be one potential path, like a synthetic
Yeah.
replacement. Yeah. And then you compare that with like all the work that's already going on in like brain computer interfaces. So that's already extremely well funded. There's multiple
Mm.
companies in that space. Elon
Right.
obviously has Neuralink, and that seems like feasible. Like it's already somewhat
Yeah.
functional, right? Like,
Yeah. I mean, I
yeah,
think that looks like, yeah, like it's gonna be the one of future iPhones that everyone
yeah.
will have, like some sort of a interface. I want to take a quick break to let you know that you can now get my new book, The Longevity Leap, on Amazon. It contains 24 chapters ranging from the biology of aging to all the major chronic diseases such as heart disease, kidney disease, neurodegeneration, and I also cover over 70 clinically relevant biomarkers for chronic diseases and their optimal ranges. You can get the book from the link in the description. But I think that can also be like a segue to the second step in the roadmap, which is a biostasis of pausing aging indefinitely in the body. And, if you like pause aging of the organs, then you don't need to replace them either, theoretically. Or if you like reverse through epigenetics somehow from a old heart to a young heart, your body would regenerate itself. I guess theoretically it would be possible. Some species do it, like some of the jellyfish and such. So yeah, what can you tell us about that?
Yeah. So yeah, biostasis is one of the other paths in the LBF roadmap, one of the three. And in some sense, it's not really a full solution for aging. So it's kind of sneaky in that sense. It's more just trying to pause biological time, potentially for not indefinitely, but like for a very, very, very long time. Like,
Hmm.
so yeah. So basically, with biostasis, um, there's kind of like two main paths there. I would say maybe three, two and a half, let's say. So the first one is, cryonics or cryopreservation. So we already cryopreserve certain cells, right? People can freeze their eggs, people freeze sperm, etc. And at extremely low temperatures, basically most biological processes, or well, basically all biological processes, come to almost a halt, like almost a standstill, right? And so in that way, you could potentially preserve, the your tissues, your brain, your body in a certain state for I don't know, definitely thousands, maybe more amount of time, and then the strategy is, yeah, that gives you time to actually, for civilization to develop the technologies necessary to both, revive you, but also solve the biomedical issue that kind of like necessitated, putting you under cryostasis in the first place, right?
Mm.
So that's kind of like the biostasis philosophy, and you can do that with low temperature. You have to use like certain things like cryoprotectants to prevent ice formation, which kills cells and so forth, and kills tissues. But that's kind of like one branch. There's also a smaller kind of like field within that field, looking not just at cryopreservation, but also like chemical fixation. So you might be able to preserve using like certain aldehydes, like glutaraldehyde and so forth, chemicals that basically cross-link all your proteins. So it just kind of like uh, uh, glues them in place, essentially. Um, but the issue there is with chemical fixation is it's very difficult to undo those chemical changes, and it might require just like really, really, really advanced technology. Some people think that maybe you don't even unglue it at all. And what you would do is you just preserve your brain, and then you would like scan it somehow destructively or whatever with like slice it into into
Mhm.
very thin slices, and then reconstitute it like in a computer and do an emulation. I think that's like really in the realm of sci-fi. Although you know, people have been mapping, connectomes of like model organisms, like the fly, I think was just recently done. Uh, so yeah, that's maybe one potential path. And then the other one, the kind of like the 2.5, is maybe like something that's more gentle, like a hibernation of some sort. So you know, certain mammals are very good at hibernating. They can reduce, like certain squirrels, bears and so forth. Um, they can reduce their like metabolism to like 10% of what the normally runs at. So if you believe that you can reduce like all metabolism to like 10%, then maybe you could extend your lifespan
Mm,
significantly if put into like a hibernation sort of state.
right.
Um, so that's kind of like the situation with the biostasis path, and people are working on this. There's companies just recently. Laura Deming, who used to be was the founder of the Longevity Fund, which was the first longevity venture fund. She was a Teal Fellow. Yeah, she raised I think $40 million for a company called Cradle Health, and they're basically their mission is to demonstrate reversible cryopreservation biostasis. And yeah, there's a lot of interesting interim applications for this stuff too. Like back to the organ shortage sort of thing. One of the reasons why we have so few viable organs for transplant is like when someone dies, right? Like we can't there's no way to like preserve that organ at room temperature. Well, no good way to do that for a long time, right? So generally speaking, you always hear about like someone dies, they have to like put this heart like on an emergency plane and then ship it to the person and then and do the transplant surgery immediately because there's just no time, right? But if you could actually bank these organs, then you could actually increase the supply significantly because then any person who just like dies and is on the donor list, the organ donor list, you could just preserve the organ and then wait until it's needed, right? So so people have been preserving organs of like of smaller mammals, so like rats and also rabbits. I think the kidney of those organisms have been successfully cryopreserved and then rewarmed and then transplanted back into an animal and functional. So there
Mm,
are some like early proofs of concept that this is definitely possible. But still early days.
mm, right. I guess, yeah, like you could, cryo freeze your DNA or something as well. And maybe in a few thousand million years or something like that, they'll be able to resurrect you from your DNA or something like that.
Oh yeah, well, cells are very easy to cryopreserve. So
Mm,
you could cryopreserve your cells today, and someone could potentially clone you in the future if you are interested in that.
mm,
Um, but other things that people are doing, have you heard of this company, Forever Labs? Um,
I know.
Okay, yeah. So they do bone marrow banking essentially. So
Mm,
you can extract bone marrow. If you're younger, it might be you could basically take the young version of your bone marrow, bank it, and then you'd have these stem cells, which are the bone marrow stem cells are basically the cells that give rise to all your blood cells, right? So and also your basically the immune cells, right?
mm.
So if you wanted to potentially, rejuvenate your immune system in the future when you're older, you could bank your bone marrow today. I haven't done it, but I actually know people who have. Um, yeah, so it's interesting approach.
Gotcha. Is there ways to like halt the aging of the organism without the cryo, so that you some sort of gene therapy or some sort of pills or some medical therapies?
Yeah, I mean, this is the big question. And I think that's kind of like heading more into the realm of the bioengineering aspect, right? Where
Mm,
at that point you kind of have to understand like you have to develop a sufficient understanding of what are the things that are going wrong, right? Or what are the processes that actually lead to aging, and how do you and actually intervene to halt them or slow them down, or potentially even reverse them. So there's all sorts of different philosophies around like what should be the best path going forward. But in terms of like doing, but if you wanted to do just like biostasis with like just taking a pill, I don't know that I don't know of any way to do that right now, other than maybe something like a hibernation. So I know there are, I think there was a paper I saw where people tried to stimulate like a certain part of the brain in a rodent, like in a rat or a mouse, and then try to induce like a torpor state so that it would reduce its metabolism. Um, so maybe there's something more in the hibernation realm where you could slow down biological time, let's say, but I don't know that you could halt it in the same way that you know you would be able to with like just chemistry physics, which would be like
Right.
the cryopreservation or chemical fixation route. Yeah.
Gotcha. Yeah. I guess, yeah, then we can go to the third last step, bioengineering.
Yeah. So bioengineering is, in my view, the hardest and potentially the fuzziest branch on the LBF roadmap. And the reason being is basically, yeah, bioengineering is your default mode where it's basically, hey, there's all this stuff that's going on in biology. We just have to like sufficiently understand biology or develop the tools to understand it, which could involve like AI models and et cetera, right? And then once you kind of like have a sufficient understanding or model of what's going on at the cellular and molecular level, then you have to start intervening, and that's also extremely difficult. Just being able to, let's say, genetically modify every cell in your body, like with precision and efficiency, like that seems very difficult. Um, yeah, and maybe you could use also cell therapies, engineer different cells to do certain things and different functions. But at the end of the day, yeah, it probably will involve some sort of capabilities to do genetic modifications at scale, which currently people are trying to work towards that. Like gene therapies exist. There are FDA approved gene therapies. But generally, like those gene therapies, like the delivery methods are quite crude in compared to what we would like to do, which is basically have full control of all the genome, like the entire genome in all your cells, right, and all different cell types. Whereas today with gene delivery, most people are using like AAV vectors or lipid nanoparticles, but these generally have like a couple different problems. Like one, like a lot of these vectors, they have a certain affinity to different tissue types, so they don't go to all the cells in your body. They'll like usually localized to certain tissues, which is fine if you're trying to solve like a disease that's localized to a certain tissue. But for aging, you would need to be able to address the vast majority of all the different cells in all your tissues, right? So that's one problem. And then the other thing is like redosing, which is just like, yeah, being able to repeat these gene therapies, because like potentially, you do it once to rejuvenate, but you might have to do it again and so forth to continue rejuvenating. So yeah, so that's also another problem. But yeah, it's very difficult for me to see like how this is all going to fully pan out in the bioengineering realm. People are working on, like, for various reasons, just trying to develop these capabilities for addressing, just normal diseases, not even just for aging. But yeah, potentially, if we develop like very advanced AI, there might be some breakthroughs in maybe the understanding of aging, with like, if we just generate like massive data sets on everything that's going on in the body at different ages, like longitudinally, and then just like crank it through this, these LLMs or whatever, these neural networks. Maybe, I don't know, but that's like pure speculation. It's just like not clear to me within a like 10-year time frame that you could solve this without just like I don't know, allocating massive amount of resources to this problem. And even then, maybe it's just far beyond reach, right?
Right. What would be like the first important step to focus on? What do you think is the biggest like first barrier right now?
Yeah, I mean, there's a lot of different opinions on this. So some people would say that just doing like pharmaceutical interventions, small molecule drugs, like we have small molecule drugs that slow down aging, quote unquote, or extend lifespan in model organisms like rapamycin, right? Like this is a very well known. Actually, do you take rapamycin? Can I ask you that?
No,
Okay,
I don't
yeah,
take
yeah.
it right
And
now.
apparently, Brian Johnson recently stopped taking Rapa, so all the Rapa bros are in shambles now, I guess.
Right. Well, I
Yeah,
think that's the most likely to work right now. So like
yeah,
any other supplement isn't gonna extend your lifespan probably, but rapamycin probably will a little bit.
yeah, yeah. I mean, I don't take rapamycin, and I'm not a doctor. This is not medical advice. I'm just saying, yeah, in some sense, you can think of like these pharmaceuticals as like a very crude, primitive bioengineering, where you have some sort of model of what's going on, like mTOR pathway, and then you're like, okay, and I have this very crude device, which is a small molecule, to try and drug this target, and maybe that could slow aging a little bit. Um, but generally speaking, I think most people who are even developing these small molecule drugs for aging would agree that most of this stuff is going to be small effect size. Like even in mice, like rapamycin only extends lifespan by like maximum lifespan by like 10-15% in mice. And this is like the best, most well characterized anti-aging drug that we have in mice, compound or whatever. So that's maybe one way to do it, but then we're getting back into the kind of like, oh, what we're really trying to do is just like show the first proof of concept, and that would just wake up the world to actually invest more money into like the actual stuff that would get us over the line to indefinite lifespan. So yeah, I'm glad people are working on that. I don't think that's like a bad idea by any stretch. I think it's definitely a plausible model of what's going on, but I also think that we need to be working on like the actual technical stuff that would get us over the line
Yeah.
now, today, not just in the future when everybody has woken up to it. So in that sense, what I think people should, be working on, in my mind, is probably like, yeah, just better gene delivery, right? So let's say you just wanted to brute force this problem, right, and figure out like how can we reverse aging or slow down aging drastically in mice, as a proof, as just like first, so and then try it in primates and then humans, and you know, I think for the strategy there, given time constraints, like if you're trying to save people who are alive today, right, and just do it as quickly as possible, then you probably want to show age reversal, right? Because if you're just slowing down aging, it just takes a really long time to detect that. Whereas if you can reverse aging, right, that's going to be a very strong signal, and you'll see it immediately. I think this is very in line with like what George Church is trying to do, in his perspective on, yeah, let's focus on reversing aging. So
Mhm.
in that light, okay, how would you demonstrate reversal of aging? First, maybe in a model organism, and then move it up to like primates and then humans, clinical trials. Well, to do that, you'd have to have some sort of like genetic intervention, probably. But how do you actually do that? Well, there's two ways. You can either do like a transgenic breed, so you would start like by like modifying some embryos or whatever, creating like a strain of mice, and then letting them, I guess, develop to maturity, and then maybe you turn on the genes. People have done this with like OSK. Actually, they've done this with like senolytic mice. Anyways, yeah, it's kind of besides the point. Um, but that takes a long time too, right? Like if you're just creating these transgenic feeds, letting them like age, and then turning on the genes and
Mm.
seeing what happens. Mice live for like can live like 2 to 3 years or something like that. So that would take a long time, even if you did it at scale. So actually, what you probably want to do is develop better delivery, like of genes, so that you could just have like a massive warehouse of just like of mice, right? And then once they get to a certain age, so you just have like constant stream of old mice, then you can just like deliver these genes to their entire body, and then just say, okay, now that I have like great control, fine control over these genetic interventions, now we can just like multiplex and just like try different combinations at scale, at like incredibly large scale, and then feed this into probably some sort of AI model to see like, and then measure. And that's also tricky. Like, what do you measure? And then feed this back into a model, and then try and propose what the next set of interventions should be. Right.
Mm.
So there's that. Or you could try doing something where, if you had really great modeling, you could just try and do this all in silico and just like skip the mice altogether. But that seems very far even now today, because like people are trying to simulate even just like a single cell, and that's like very difficult, right? But yeah, if you had to ask me, the path forward, if I had to just brute force it, yeah, focus on gene delivery technology, and then just do this on mice, different combinations at scale.
Mm. Yeah. Yeah, it makes sense that like gene therapy is probably going to be the more effective, like the more what will deliver the results. Yeah, like the drugs or something like that. You're not really replacing the organs or something like that. So the gene therapy is probably going to be more important.
Yeah. And I think the important thing to say is that like people are already trying to develop this capability, even if they're not interested in aging, because it's just like useful for treating different diseases. Yeah. So that's one, I guess, bright thing to be like optimistic about.
Yeah. Yeah. Like I guess we can start wrapping up. And you also like are one of the co-founder of this Vitalist organization, which, as I understand, is like a you can maybe like explain it a bit better.
Yeah. I think maybe the question that I should start with is my favorite question, which is, how long do you want to live?
Like I've always liked the idea that okay, we figure out how to live forever, but then everyone chooses to die like at some point. Like that would be like, because there's no virtue in dying because you can't choose, but there is virtue in choosing death if you have the option to live forever. If that makes sense. Like no one is virtuous for dying because no one else, because there's no other option. Like everyone will die as of now. But if you have the option to be immortal, but you choose to die, then that's kind of a more virtuous approach.
Okay, that's interesting. I've never heard anybody give that answer before. Because I've literally asked, I don't know, hundreds of people, maybe almost 1,000. I don't know, because this is one of the questions that we ask on the application form for Longevity Biotech Fellowship. And I also have gone around like different cities in the world, just doing like street surveys, asking random people on the street how long they want to live, my Uber drivers, whatever. And I can tell you that it's strange. Do you know what most people say, actually? Can you guess?
They'll say something like 60s, 70s, they want to die before they get the problems of aging.
Yeah, kind of. Actually, okay, so I would say 80% of people will tell me something like 80, 90, or 100, right? Like 80% of people say that. And then the other 20% will usually say something like, like a really big number. They might say like 500. Some people will say forever, obviously, right? And then other people, yeah, I've heard some like weirder answers where it's just like, yeah, tomorrow or something like that. Unfortunately, some people are unfortunately depressed. But yeah, this is an interesting question, because it really strikes to the heart of, why do any of this at all, right? Like why get involved in longevity? Why should we work on, developing therapies for aging? Why, I don't know, why do any biohacking or anything like this, like and diet nutrition? Like at the end of the day, right? If we're really asking ourselves like what's important in life, like what are the things that are truly like impactful, right? You have to look at what society really values, right? And at a deep level, I think everybody understands that life is good, right? Like, and death is bad. Like, this is like a fundamental feature of most like philosophy systems, religions, and so forth in society. Like, we know that life is good and death is bad. We try our best to preserve life, and death is just horrible. Like, it's just like it causes so much pain for so many people involved, and it's the ultimate extinguishing of like of choice and like optionality, right? Like, it's just like a cessation of potential experience, right? And this is bad, right? But despite that fact, right, like we have, I think people are obviously awaking to this idea that death is, or sorry, aging is the thing that causes most death, right? Like 80% or so of people alive today are basically on track to die of aging and age-related diseases, essentially, right? So that's cancer, Alzheimer's, what have you, heart disease as well. Um, and this is not just like a feature of just like wealthy nations, right? Like this is rapidly happening to like the developing world as well. So so then the big question is like, why aren't we doing anything about this? Right? Like it seems just like insane that we devote so few resources to the thing that happens to be killing the most number of people, right? Like so just to give you context on like how little resources are actually devoted to aging. So in the US, the main funder of biomedical research is the NIH, but less than I think it's about 0.5% of the NIH budget is actually devoted to studying fundamental aging biology. So the thing that is killing the most people. So only 0.5%, right? So this is ridiculous, right? Like, this is like we should be up in arms about the current situation that basically nobody cares and nobody is trying to do anything about the thing that is killing the most number of people. So for us, I ended up co-founding this nonprofit and this essentially social political movement with Adam Grease to basically it's a returning to this fundamental moral precept that life is good and death is bad, and if aging is the thing that kills most people, then we should definitely make this our number one priority, right? Like, fighting aging and death should be humanity's number one priority. And so that's basically what we're trying to do with the Vitalism Foundation. Create this movement to advocate for actually devoting massive amount of resources. And what we're trying to envision here is like an Apollo program for aging. And why not? Like, people we've humans have been able to do like really incredible things and devote a massive amount of resources to things that are really important. And we're just trying to highlight that this is we're coming to the point in time where we have the ability to actually start thinking about actually solving this problem of aging, whereas maybe in the past, it has been out of reach. So we're trying to, raise the awareness and raise the alarm. Basically, say, hey, this is happening. This is an emergency. We need to do something about this, and devote the appropriate amount of resources to doing fighting aging and death. So what we think is an appropriate amount of resources is about like 1% of global GDP, and Elon actually recently had the same idea, but for like making human life like multi-planetary. He's just like, yeah, this is an important thing. We should devote 1% of resources to fighting or to going to Mars and establishing a colony there, and for other purposes, for other like causes as well. Like, I think it was in the 70s or something like that, the UN came together and they jointly decided that they should devote, I think it was like 0.7% of GDP to like world GDP to fight like poverty or something like that, right? Like, so I think these are grand and goals that like civilizational goals that we should really be thinking about. And aging is like by far, to me, the one that stands out the most, because it is killing people today, right? Like hundreds of thousands of people are dying of
Yeah.
aging and age-related diseases today. Yeah.
Mm. Yeah, and I mean, with that, it's like the same with like the Apollo project. There's a ton of other valuable things that came from that, like refrigeration and whatever
Yeah.
other everyday things that we actually use. So with if you have like a massive Manhattan project for aging and longevity, life extension, then you'll in the process you'll figure out how to probably cure cancer and other things as well. So yeah,
Yeah, absolutely. I mean, like, just, from our conversation of all these like tools that you would develop or technologies, they could be useful for all sorts of different things, right?
yeah,
So like gene delivery could be useful for treating various diseases, some that have nothing to do with aging, and also like replacement. Like if you got in like an injury, car accident or something like that, even though that's not aging that's killing you, you would still need potentially replacement
yeah.
organs, critical parts, etc. So yeah, you would probably develop a lot of useful technologies in the process as well. Yeah.
Mm. So right now, do you like, yeah, like, do you have like some sort of investment fund or some projects that, where people can like direct their attention or focus?
Yeah. So the first thing to do in any sort of like movement is basically find the people who agree with you, right? So it's kind of a unique situation with vitalism in the sense that it's kind of a natural philosophy in some sort of way. Unlike certain religions, basically all religions, where it starts with one person who comes up with the idea and has to like convince everyone around them to join, right? And then like it's
Right.
like one by one. Uh, this idea of vitalism, right? Like that, life is good, death is bad, and we need to fight aging and death. Unlike other religions and philosophies, actually, vitalism is unique in the sense that a lot of people just come to this conclusion on their own that, life is good, death is bad. I should do everything I can to fight aging and death. So, in that sense, what we're trying to do, the first step is just to find all the people who already agree with you, who already, just came to this conclusion on their own, which there could be like hundreds of thousands, if not like millions of people around the world who actually already believe this. But the only thing, the tricky part is that there's never been a way to identify and rally around like a common like identifier around this. So just coming up with the name vitalism, giving it a definition, and making it clear is kind of like the first step, so that people can actually say, "Yeah, that's something that I already believe, and we should definitely work together to try and achieve this common goal." Right. So it's the idea of like coordinating uh, around like a clearly defined word, right? An ism. Whereas if you just said, "Oh, we're trying to find all the people who are interested in longevity," like that word doesn't mean anything anymore, because some people think, it means like health span and like, diet interventions and stuff like that. But for us, it means a very different thing. So yeah, so the first step is to just like gather together and coordinate the people who already are working on this and who already believe this. So so we have a community. It's you guys, if people listening to this, if this resonates with you, you can check it out at vitalism.io. And then once we have like a certain critical mass of people who are working together, connected in a community, then we can actually start pushing things on the political stage, because it's not enough. Like I think it's great that people are working on the science and the technology, building startups and so forth. I think that's really important. But at the end of the day, we're in this situation where there's just so few resources dedicated to the problem. We're just taking so few shots on goal. Whereas what we really want to do is do something like a Apollo program or Operation Warp Speed to solve this problem of aging. So in order to do that, you need to get into the political game, right? Like there's no other way around it. So there's different ways that you can conceptualize this, but a lot of it is just both the traditional sort of awareness campaigns, grassroots sort of like, talk to as many people, do more, science advocacy, public awareness. But then there's other things, other strategies that can be employed as well, which are more, let's say, in the realm of like, how could you like short circuit or like hack your way into political prominence. A couple different models there. So Balaji Srinivasan had, proposed like this network state idea, right, where basically you take like a internet first community, and then they, come together, they connect, and then they crowdfund, territories around the world, and then have an on-chain consensus of their GDP and so forth, and then get to political recognition. So that's like one extremely new way that's being tried. Other things like the Free State Project in the United States, where basically a bunch of libertarians got together and said, "Hey, what if we all, did this like densification and concentration of people who are politically aligned in one place, like one political jurisdiction, so a state in the U.S." And they selected New Hampshire, and then now they've become kind of like a political force there. And so there's different ways you could think about this, and similarly, instead of like a free state project, you could do something like a longevity state project, where it's just like, hey, how can we get to like that first rung of political significance that people would recognize you? And you could do something like a political migration. So these are like different things that we're looking at Vitalism Foundation and in developing the roadmap for. But then the other thing that I want to mention, which we're really excited about, and we just recently announced, is Vitalist Bay. So this is an ambitious project that we're undertaking. It's basically a 8-week longevity zone that's going to be centered around Berkeley, California. Basically, trying to take over this city for 8 weeks to make it like a place for where longevity is the number one priority, and we're bringing in, inviting, thousands of experts from around the world in all different domains, not just like, science and technology, but also policy, health and wellness, also people from crypto and DeSci and so forth, and bringing them all together with this common goal to spark essentially, a Manhattan Project, Apollo program to solve aging, right?
Mm.
And so that's happening next year, or sorry, not next year, this year
This
now,
year, yeah.
because now it's January. It's happening in April and May of this year in Berkeley, California. It's 8 weeks. We have 8 weekly themes around longevity, different lenses to attack this problem of aging. And we have this campus that we've secured for 2 months. It's actually at Lighthaven, which is kind of like this campus that the rationalists, the rationality community people who run like Left Wrong and so forth have. And so we've rented this for 2 months. It's basically combining both like longevity first co-living, so we're going to make like the most healthy environment in the world, centered around this campus. And I think basically 70 people can live right on campus here in Berkeley. But we're also going to have like events, so conferences. So every week there's going to be some sort of event around these 8 weekly themes, everything from longevity science, health and wellness, to investing, DeSci, policy, etc. And so we're super excited about that. And if people are interested in getting involved in this in this event, they can check out our website at vitalistbay.com. And looking for people who are super ambitious, who want to join us either as like as a resident, or if you just want to come to the events, maybe you already live in the Bay Area, then that's cool too. So that's happening in April and May of next year. LBF actually is also going to be kind of like a affiliated event just right before that. So March 31st to April 4th at the same location. So if people are interested in, getting involved on the technical side, connecting with other people who are building projects, and want to get up to speed on, on the different technologies to solve aging, they should check out our website at longbiofellowship.org and apply for the next cohort, which is our 6th cohort, actually, going to be in Berkeley this year. So that's the idea. Just for Vitalist Bay, just create the most noise and energy and I guess the density, right? Like of bright people and ambitious minds together around this common goal. And yeah, we're going to be doing it in the Bay Area, which is essentially, the place where I think there's a lot of latent interest, right, in
Hmm.
these sorts of ideas, but also where a lot of the tech influence and capital, and I guess that's where the tech culture emanates from. So if we can really make this like the biggest, longevity cultural event in all of history and frame it in such a way that it's ambitious and saying, hey, yeah, we actually have to do something about aging, and because it's an emergency, then yeah, then we can actually spark something really amazing there and have a chance at actually trying to solve this problem. So that's kind of our grand ambition and our grand goal.
Yeah, that sounds awesome. And we'll put links in the show notes for people to check it out. And where can people learn more about you and your work?
Oh, yeah, I guess the easiest way is to follow me on Twitter. That's where I'm most, or X, where I'm most active. So yeah, real Nathan Chang. Um, but I also have a newsletter, which I always say I'm going to, release the next newsletter, but I've been just so sidetracked with all these different projects. So people can subscribe to that Substack. I think there's a link in my profile on X if they want to find it, but it's a longevity market cap newsletter.
Hmm.
And if people are interested in the work that I do in venture capital, in investing, they can also check out Healthspan Capital. .vc. So that's our website. We're actually a fund that's publicly available on AngelList. So basically, any accredited investor can technically join our fund. That was kind of like one of the reasons why we started the fund in the first place, to make it kind of like semi-democratize and allow people to have exposure to these investments, because yeah, it's difficult to have exposure unless you join one of these really large funds. But yeah, so we're like a rolling fund on AngelList that people can access as well. I think that's mostly it. Yeah, and then Vitalist Bay is you can find that at vitalistbay.com if you want to apply to join us there. And I think that's mostly it. Oh yeah, vitalism.io. So if you're interested in joining this community and this movement to make fighting aging and death humanity's number one priority, then you can check us out also at vitalism.io.
Sounds good. And my last question is, what's this one piece of advice or habit that you wish you'd adopted sooner?
Oh, okay. Yeah, this is a good one. Good question. Um, yeah, okay. So the context here is with the Longevity Biotech Fellowship, we do this like 4-day workshop retreat where we're bringing in these newcomers, we get them up to speed, connect them with each other and also mentors, and et cetera, et cetera. But then we do this thing, these mastermind groups afterwards as an online program for the cohort after the workshop retreat. And one of the things that we did with these mastermind groups that are led by some of the mentors, I lead some of the groups as well, is we went through this book. I don't know if you know this book, The Great CEO Within.
No.
Okay, so maybe my answer is read that book,
Okay.
which I wish I had done sooner. Well, not just read it, but like actually try and implement some of its practices. So basically, the book, it's written by Matt Moshari. He's a CEO coach, and he was a CEO coach to many of the, some of the top Silicon Valley CEOs like Sam Altman, Brian Armstrong at Coinbase, et cetera, et cetera. And it's structured in such a way that it's just like a bunch of short recipes, just basically standard operating procedures on just how to get stuff done effectively, right? Both in yourself, but also in teams, right? And so there's a lot of great advice in there. I don't know if I want to get into too many, but one of the ones that I felt was really important was, yeah, basically having weekly reviews, right? Like actually setting out time to write down and reflect on your week and what lessons you've learned and how to improve. Because I think if you want to, get better at what you're doing, whatever it is you're doing in life, potentially like trying to solve aging, then yeah, you need to be able to have some sort of consistent iteration feedback loop where you're saying, okay, what went wrong? How can I address this? What experiments can I try to address these issues that I've identified? And then just continually run this in a loop. And for whatever reason, like I didn't have a great system to do that. Like I wasn't very disciplined to do that. But just this year, just really, doubling down on that, on like just writing, writing for yourself, and on a consistent cadence, like in a reflective way, has been very useful in my life, at least. Yeah, so I recommend it for everyone else.
Sounds good. Well, it's been a very insightful and interesting conversation, and definitely looking forward to what's going to happen in the next few years and decades. But thanks for coming to the show, and I'll see you around.
Awesome. Thanks, Siim.
All right, that's it for this episode. Make sure you check out my new book, The Longevity Leap, on Amazon. I'd also appreciate if you share this episode with a friend or family member. Other than that, my name is Siim. Stay tuned for the next episode. Stay empowered.